In this video, we're going to look at the graphs of the last two trig functions, the tangent and the cotangent. So we have, first of all, y equal tangent of x, and I wrote that as a fraction sine of x over cosine of x, so we can see where this is undefined. And of course, a fraction is not defined if the denominator is 0. So we saw in earlier videos that the cosine function is 0 at odd multiples of pi over 2 or 90 degrees. Okay, so that's when this is going to be 0. So therefore the domain of the tangent function cannot include the odd multiples of pi over 2. So those are restricted. And as you'll see from the graph, the range is going to go from negative infinity to infinity. Now the sine function is 0 at multiples of pi. So it's 0, pi, 2 pi, 4 pi, negative 2 pi, and so forth. So we would expect the graph, and we're going to sketch one period of the graph, and then we'll do the graph on the calculator. But basically then, the graph is going to cross the x-axis at the point 0 radians, at pi, 2 pi, and so on. And because it's undefined at the odd multiples of pi over 2, you would expect to have vertical asymptotes. Okay, so we have one at pi over 2, at minus pi over 2, and we would have one at 3 pi over 2, and so on. But let's look at the graph from minus pi over 2 to pi over 2. So again, if you have a vertical asymptote in an interval, you would expect the graph to approach it. So let's look at the interval from, say, 0 to pi over 2 radians, or 0 degrees to 90 degrees. So if you evaluate the tangent function for angles from 0 to 90, you're going to get positive values. So this graph is going to go up like this. Now if you evaluate for angles between, say, 0 and negative pi over 2, or say 0 degrees and negative 90 degrees, really negative values, this is going to come down. So the graph is going to approach this asymptote. And then over here it's going to repeat. It's going to go like that. Then over here, the same thing. Over here on this side. So we saw in the previous videos that the sine, the cosine, the secant, and the cosecant had periods of 2 pi or 360 degrees. The tangent function, as well the cotangent function, will have a period of pi. In this case, the main period is considered to be between negative pi over 2 to pi over 2. Okay, even though we can look at a period over here, okay, or further down to the left, to the right, or to the left. So that's what your graph looks like, and you can see that just if you look at this interval here, it goes on up forever, positive values, negative values. That's why the range over here, or the y value, goes from negative infinity to infinity. So now, if we look at the graph on the calculator, okay, I have selected here the tangent x, and notice here I don't have to have it use the sine and cosine, because that's tangent is included on the calculator display here. So I just hit graph, or I can do it zoom 7, whichever one works the best. So let's do it zoom 7, and you can see the graph. Okay, so if we just go along the x-axis, there it's right there. Of course, it's 0. In this case, I have it set to degrees in the calculator, so this would be 0 degrees, which corresponds to 0 radians. So if I keep going here, okay, at 90 degrees, or that would be pi over 2 over here on the graph that I have, you have a vertical asymptote. The calculator doesn't show it, but right here is a vertical asymptote. I'm sorry, right over here, this one, this one over here. One over here also, but we're looking at this one here. Okay, and then if I go to the left, again, go through 0, and then I get to negative 90 or negative pi over 2 over here. Okay, so you have your vertical asymptote here. You can see how it repeats. Okay, so we have a period from minus pi over 2 to pi over 2 is your main period, and that of course is has length of pi. Okay. Okay, so let's clear this now. And then we'll clear this one. Now let's look at the cosine function. Y equal cotangent of x, which I can write as cosine of x over sine of x using one of your basic identities. So again, the denominator is 0. Sine of x is 0 when x is a multiple of pi. Okay, so at 0, at pi, at 2 pi, at 3 pi, negative 2 pi, negative 3 pi, and so on. So since those values make the denominator 0, it's undefined there, so the domain is restricted. X cannot be k pi, where k is an integer. And as you'll see from the graph, it's going to go from negative infinity to infinity, similar to the tangent. So over here then, this one is going to have the vertical asymptotes. Again, you look at this, undefined at multiples of pi. So it's going to have a vertical asymptotes. Let's see. At pi, okay, and of course at 0, which would be the x equals 0, which would be your y-axis. So let's do it this way, okay, and then also have it at that 2 pi over here and a negative 2 pi over here, and at the odd multiples of pi over 2, the value will be 0, okay, for cotangent. So if I pick values less than pi over 2 or 90 degrees in this interval right here, I'm going to get positive values. So the graph is going to approach that asymptote from this direction like this. It could pass through pi over 2. And then if I were to pick values between 90 and 180 or pi over 2 and pi, I'm going to get negative values for cotangent. So the graph is going to go like this. Okay. And then over here it's going to repeat. On the left, the same thing. That's what the graph looks like. So if I want to look at the graph on the calculator, okay, so let me deselect the tangent function. And of course, cotangent doesn't have an icon here, so I have to use the basic identity. Cotangent is 1 over tangent, so I have to graph that. To graph cotangent, I have to graph 1 over tangent on the calculator. So I select this one, hit that one, and then hit graph, or you can do the zoom 7, and there you have it. Okay, so here's an asymptote right here. So the main period for the cotangent function goes from 0 to pi. Okay, so if I go along right there, I get at the origin 0, 0, x equals 0 is an asymptote. That's the y-axis. If I keep going here, it crosses the x-axis at 90 degrees, so that's the point 90 degrees and 0, or pi over 2. If you're looking at it in radians, pi over 2 and 0. Okay. And if I keep going, at 180, okay, or pi, I have a vertical asymptote. Okay, and that's what the graph looks like. And for the domain of this function, let me clear this now. Domain of this function, then x cannot be a multiple of pi. So that's what this means. X does not equal k pi, where k is an integer. The range you can see from the graph goes from plus infinity or minus infinity to infinity. Okay, that's your graph. Now this is what, again, in the last few videos we've been looking at the main period of the 6 trig functions. Obviously, if this is cotangent of 2x or cotangent of 3x, the graph will be similar, but it's going to have different period. The domain is going to be different. The range could change also depending on whether you have something added to it. Okay, but right now we're just looking at the basic graphs. Your instructor might ask you to sketch a graph of a variation of these functions. He might ask you, or she might ask you to maybe sketch one period of the graph without the calculator. Okay, so learn how to do it in the calculator, and also know how to do these sketching the graphs without the calculator. Okay, thanks for watching then, and we'll see you in the next video.